Hello, everyone. Good afternoon, and welcome to today's webinar on Arc Flash PPE and the changes to CSA Z46224 Workplace Electrical Safety Standard. I'm Rachel Polanski at GoTo, and I will be your moderator for this session. Before we get started, I would like to go over just a few items so you know how to participate in today's event. When you join today's webinar, you selected to join either by phone call or computer audio. If for any reason you would like to change your selection, you can do so by accessing your audio pane in your control panel. This presentation will be recorded, so no need to worry about taking notes, and we will send out the recording after the webinar has concluded. We have also allocated time at the end for questions, which you can submit through the questions pane in the control panel on your GoToWebinar panel. You may send in your questions at any time. We will collect these and address them during the Q&A session at the end of today's presentation. Joining us today is Leslie Mullen, Personal Safety Market Segment Manager at Levitt-Safety, and Jim Pollard, CESCP at Unlimited PPE Inc. Without further ado, I will now pass the conversation over to Leslie, who will provide a brief introduction to today's topics.
Thanks, Rachel, and thank you everyone for attending today. We are really excited to be able to bring you this webinar that focuses on CSA Z462 standard, and very happy to have such an industry expert such as Jim to take you through the key changes of the 2024 version. Understanding this standard will help you with compliance and provide you with the information you need to mitigate risk and increase your workers' safety. And now I'll pass it over to Jim to start the webinar.
Thank you so much, Leslie, and welcome everybody. So thank you for the introduction. So again, my name is Jim Pollard. I'm at Unlimited PPE, certified electrical safety compliance professional. I represent the SureWorks group, worked with the Oberon company for the past almost 16 years. Voting member on several different committees, including the CSA Z462 standard, of course. Other committees include ULC, ASTM, and others. Currently acting as the chair of the subcommittee on communications for Z462, and super happy to be here to go over a presentation with you today. The team that we have at Unlimited PPE does span across Canada, so we offer consulting, training services, in addition to what we do for SureWorks and the Oberon company. We are dedicated to providing workplace electrical safety compliance and due diligence solutions in an end-to-end fashion. So most of what we do would be customized for individual clients. The agenda for today's presentation, we're going to go over a quick introduction, which we've already begun. Why the need for change, and discuss the impact on you, I believe, if you're the employer in this scenario, and then understanding the changes that are anticipated in the draft of the 2024 edition of CSA Z462. And I've also thrown in some different elements related to Arc Flash PPE, so perhaps some innovations that you weren't aware of yet. And then we're going to discuss some next steps, so the expectations for you and how you would manage the change management that results from the publication of a new standard, and then we're really hoping to have some time at the end for interactive Q&A. Quick disclaimer, so the information presented is not a complete account for all the proposed changes and updates to the 2024 edition of Z462. Couldn't possibly cover everything in one short hour, right? The information provided in this webinar is a technical interpretation of myself as the presenter, and it is not an official interpretation from the CSA group. Levitt-Safety, Unlimited PPE, and myself, Jim Pollard, we accept no liability for the information provided. It is simply information only. You are advised to consult the CSA group directly and the CSA Z462 Technical Committee once the 2024 edition has been published for formal interpretation. So what that means is if you have questions related to the standard, it is best to go directly to the CSA group. And of course, you need to own a copy of the standard to actually have access to it and be able to read it. So we're happy on the tech committee to answer questions, but that is the path that you should go. So as part of the introduction, just a quick read. We have in North America, you have two different standards that apply to workplace electrical safety. or electrical safety in the workplace, if you read it from the 70E perspective. And if you have CSA Z462 that was began from the NFPA 70E, so that became the seed document for what we adopted into Canada. And the first edition of CSA Z462 was published back in 2008. So I believe it actually saw the light of day in January 2009, but has a published date of 2008. It is based on and technically harmonized with the NFPA 70E. There are differences, though, between the two standards, and those differences, or the divergence between the two, began back in primarily in 2021. We've had differences all along, but there were some substantial differences in 2021, and there will be additional differences in 2024 between the two standards. That's a good topic if you want to discuss offline. Perhaps your organization has operations both in the US and Canada. Maybe decisions are being made for your workplace electrical safety out of the US, and then you'd be, I would think, very interested to know what the differences are for compliance in Canada. And that would be a great topic, maybe for another webinar that we can host for you. So the Z462 standard is built based on the following clause structure. So there's scope, there's reference publications, definitions, safety-related work practices. So this section 4 is where we spend most of our time in today's presentation. That is where we cover the working with electrical hazards section in the standard. Then we get into maintenance requirements, which is section 5, and section 6 is for special equipment. And then we have annexes. I know it's been described by many in the industry that from the American perspective, that from 70E compared to Z462, that the Canadian version of that standard has annexes on steroids. We have several annexes that 70E does not have, and we were able to beef up and add a lot of innovation and content to the annexes on the Z462 side compared to 70E. So there's a lot of learnings that can come from just reviewing the informational annexes in the standards themselves. And then in 2021, we introduced a new normative annex. So not all annexes are considered informational, or we have one that's normative, and that's Annex V, and I'll cover that in an upcoming slide. So the landscape of updates for Z462 began, as I mentioned, in 2008, and we're here discussing what is coming for 2024. Every 3 years, we publish an updated revision to the standard. This is admittedly an aggressive revision cycle. It's unlike other standards in the CSA group or the CSA world that would follow a 5-year revision cycle. Z462 is unique in that it follows a 3-year cycle, and that aligns with the Canadian Electrical Code. It also aligns with the NFPA 70E revision cycles. And if you're really interested in electrical safety, I encourage you to contact us offline if you're interested in participating in some of the 2027 discussions. So if you want to have an impact, there's an opportunity to submit comments to the standards development process. We begin work on the 2027 edition of CSA Z462 early next year. So it's only a few months away. Now, why the need for change? I mentioned it is an aggressive revision cycle, and there are some reasons for it with the alignment to the Canadian Electrical Code and 70E. But beyond that, this revision cycle every 3 years does allow for improved safety, allows us to capture industry best practices, technological advancements, risk reduction, and continuous improvement. So the electrical safety industry is rather young compared to other industries. If you think to, eye and face protection, where we've had products in the market for 100 years, with electrical safety, it wasn't until really the mid-90s that we could do any arc flash testing in a laboratory to measure the performance of products that would be exposed to an arc flash. So we're only talking, 30 years ago. The first ever arc flash face shield was invented back in the mid-80s. So we don't have that much time in terms of the industry. So there has been a lot of changes that have occurred, and having a short revision cycle every 3 years helps us capture those changes and updates. How does this affect you as an employer? Of course, it has everything to do with your electrical safety program. That is by far the most important element that would be impacted with the publication of a new standard. How you go about your risk assessments, by extension of your program, would be the training and qualification requirements, arc flash and shock PPE selection. There's been new tables added, so new resources available for you in terms of PPE selection, equipment maintenance, incident investigation and corrective actions, and due diligence to OH&S legislation. It's important to note that CSA Z462 is still not law. It's not a requirement in any province or federally in Canada. However, it is the best way for you to be compliant with the regulations, with your legislation in your province. So following Z462 is really good due diligence to what is your legal requirements to protect workers in the workplace. And Z462, you had better have something that is equivalent to it in the event that you did have an incident and there was a subsequent follow-up investigation. Just to recap, so this again was just a few years ago. It feels to me like the ink is barely dry on the 2021 edition of Z462. And now here we are talking about 2024. But I guess as a summary of the changes, the biggest, most impactful changes from 2021 was the normative Annex V. So that was the creation of an annex that is part of the body in terms of how it would be enforced in a court of law. And in Annex V, we introduced a new improved arc flash PPE selection. This table method included a higher protection level, 5, with a minimum arc rating of 75 calories. And we also brought category 5 into the other method. So there's an older table method that, if you go back a few editions ago, it was the hazard risk category method, and that changed in 2015 to the arc flash PPE category method. And then we kept improving it in 2018, and then 2021 was an alternative to that table method, which is generally accepted to be much easier for most workers to use and to apply. We also in 2021 added new requirements for your electrical safety policy requirements and normal equipment condition clarifications. And of course, we had a new IEEE guideline published. The backbone behind the electrical safety industry is engineering calculations that are used as part of a risk assessment to determine the potential severity or injury or harm to a worker that could be a result from an arc flash incident. The 1584 guideline is what engineers would follow. So that's where you have power engineering software that's built based on the IEEE 1584 in order to conduct an incident energy analysis, or some people refer to it, or most I should say refer to it, as an arc flash study. So that guideline was updated in 2018, and it needed, or it resulted in a great deal of changes that we've published in 2021. Now fast forward to today in 2023, on the eve of this draft. It is still a draft. We haven't balloted on the draft yet at our technical committee level. And the expected published date for the 2024 Z462 is March of 2024. So we have a few months yet. Proposed global changes that you will see in 2024, as I believe you will. The biggest one here is the hazard risk categories are deleted. So here I just talked about different table selection methods based on categories, and I'm going to throw a curveball at you. Is now for 2024, the term category has been removed, globally removed, and we've improved upon the process, and I'll explain that. So the arc flash PPE category method will be changed to arc flash PPE selection table method. There's subsequent tables, so table 2, which has to do with the likelihood of occurrence as part of your risk assessment. If you're knowledgeable of risk and how it applies to electrical safety, it's a combination of likelihood of occurrence and the severity or bodily harm for the individual, for the worker. So the likelihood of occurrence component, we have table 2 that was in Z462 and now is being moved to Annex F, was a tremendous resource and will continue to be a great resource for employers that are managing risk assessments for arc flash. The difference is it's just not in the body of the standard. It's just it will be moved to Annex, to the risk annex. And then table 6A, table 6B are moved to the annexes So the table 6A was the previous method or the category method for selecting PPE. It will be brought into Annex V along with the other new method that we introduced in 2021. So in Annex V, you'll now have two different table selection methods to choose from. And then the accompanying table and annex references are updated as necessary throughout the entire document. We also made other global changes such as leather protectors changing to protectors. Of course, the biggest impactful change, as I mentioned, will be the removal of categories. And I believe this is a pretty big change because most arc flash PPE is referred to by category numbers. Here we have some selection of products from SureWorks. This is their Pioneer brand, just as an example of just how prominent the category number systems would be on the different PPE. You have coveralls. Typically, coveralls would be considered Category 2 coveralls. This rain suit would be what would be a Category 4. Previously, you would have referred to it perhaps as Category 4. Now, in the current terminology, or what will happen in 2024, is more technically correct. We should have been referring to arc flash PPE all along by its arc rating. And in the new standard, the new 2024 edition, they will require a minimum arc rating for compliance with the previous category numbers. So in the sense of the coveralls, you would have a minimum arc rating requirement of 8 calories, which would have been a Category 2 requirement. So now you can refer to the coveralls as the arc rating. So if the arc rating was 9.2, this is now a 9.2 cal coverall, not a Category 2 coverall. By removing categories, it removes a step in the process of selecting your PPE, where in the table selection method, we would have provided for you an assignment, so a category number, and then that category number related to a minimum arc rating. So in the 2024 standard, we just simply remove that extra step and jump right to the minimum arc rating. I skipped past my slide here, let me go back. I mentioned also another global change was the removal of the term leather protector and changing it just to protector. And the reason for that is we have a new standard for 2024's edition of Z462, which introduces the ability for you to use other protectors that are not made of leather, where they may provide you with additional mechanical protection for, say from if you have identified additional cut hazards in the work task, you could select a protector glove to wear over your rubber insulating glove that provides enhanced cut protection, or other mechanical hazards that may be present in the workplace. You can select other protectors that would be compliant with the standard that are not made of leather. So therefore we have changed leather protector to protector. Arc protective blankets. This is another area of innovation where we are seeing more applications within industrial and manufacturing sites. Traditionally, arc protective blankets have been used in utility applications, and thankfully, we're seeing more use in industrial applications where they're being installed as barriers. So there's additional standards and there's new guidelines that are being introduced in the industry that Z462 is capturing. So I just wanted to bring that forward. There is I have a little miniature version of a portable barrier here. This is something that the Oberon company has come up with, where you can actually assemble this portable barrier and it can contain or divert an arc flash if it were mounted properly. And then how it's installed, there's guidelines in the ASTM standards that would assist you. And we can also help you offline if you're interested in how to use a portable barrier for arc flash protection that would protect other workers that are not primary workers. Maybe you have a turnaround happening at your site, shutdown for maintenance purposes, and you have a lot of workers in an electrical room. So if you want to provide a barrier that would protect other workers from a potential arc flash, the arc curtain cube is a great solution. So I'm going to skip through a lot of these slides where there's a lot of text. I don't want to bore the group here. We can read on our own, I believe. Just to highlight one here, so one of the new definitions that is more near and dear to my heart, as you can imagine, coming to you from this office full of arc flash PPE, is a new ARC rating. And this new ARC rating is called an ARC rating limit, and it would apply currently to face and head protective products. So I don't want to get too far into the weeds, but other definitions here have to do with the capacitor hazards. We added a new section, a new annex in the standard, and a new section in the body of the standard related to capacitors. And along with the new information on capacitors comes a great deal of new definitions. Anytime you add content to the standard, you need to ensure that your technical terms are defined in the definition section. So by adding a lot of content from 70E on capacitors required us to add all these new definitions in order to have them technically harmonized. Continuing on, so we have additional definitions added due to the capacitors. The AR lim, I mentioned, applies to currently, it doesn't apply to garments yet. That's something that will be coming in the near future, I believe. But currently it applies to face shields and hoods, or face and head protection. And here you have on the screen a couple examples from the test lab that we would use most often in Spain, where we've tested a face shield, we've tested a hood, and we've applied AR limits. So that it would be an ARC rating limit versus an ATPV or an EBT. Traditional ARC ratings would be the ARC thermal performance value as an ATPV, or you may have an energy at break open threshold, which is your EBT, and now you'll have a third ARC rating, which is an AR limit, meaning that that limit, defined as calories per square centimeter, is the threshold upon which that you shall not pass for exposure to that product. You may look at the label on a face shield, and it will have an AR lim of 17 calories. You are not to use that face shield for any exposures greater than 17 calories. One of the most important components of Z462 is the requirement to achieve an electrically safe work condition. The ESWC is likely one of the most important components of the standard as you would apply it and as workers would need to understand it, and as you as an employer would interpret the standard and build your electrical safety program. We continue to put more emphasis on the ESWC. For 2024, there was a rather significant rewrite to add clarity to we removed exemptions and pointed to the Canadian Electrical Code. We didn't do that to cause confusion. We just did that so it marries up the two standards better. Energized work changed to requirement to establish, so terminology changes, and that refocuses on the requirements to de-energize. It's not legal for anyone outside of utilities to work energized, right? However, there are some exemptions to when that needs to be done, and for example, troubleshooting. So there's been exemptions that we've documented and exemptions for work permits that I'll discuss as well. But just to focus on this slide, the electrically safe work condition is one of the most important parts of the standard, and we've added more emphasis to its requirements. And now job safety planning, we've added emergency response plan as a requirement in your job safety planning. Emergency response plans, I don't think get enough love in our industry. I want to discuss that briefly here. So hope I didn't go too far, and I did. Going back in my slide again, apologies. Trying to. Okay, so traditionally for emergency response plans, a lot of employers will have, or most employers will have hot sticks or rescue sticks. So it's this gentleman here in the image is using a 6-foot long yellow stick. It's an insulated stick, and on the end is a hook. It's an 18-inch hook. It looks like a shepherd's hook. And it's expected that this tool can be used for contact release, emergency response. Now, in reality, it doesn't work that well for all of its intentions. And just in this example, we were at a facility recording new content for training development. So we're recording, taking pictures, developing new training materials for our training courses. And we're trying our best to show how an unconscious worker could be pulled by the rescue hook here. And you can see my little image here. If you try to hook this on that person's body, all you end up doing is just pulling their arm up. It's not a very effective tool if a person is laying on the floor. So what has happened in the industry over the last few years? Production of an escape strap, which is an integrated accessory that can be built into your arc flash PPE, or it can be worn as a vest over top of your PPE. So if you have a scenario where you have a small electrical room that doesn't allow for a 6-foot stick to be manipulated, or if you have a worker that's unconscious and you need to pull them out of harm's way, this is a great accessory to consider as a way to improve upon your emergency response plan as you then document this in your job safety planning. So your job safety plan would be updated, and then you'd have on there, well, do you have an escape strap on, whether it's built into your suit or worn as a vest, as I'm showing here. So that would be a recommendation as you're improving upon your documentation following the publication of the 2024 standard. This example here is a small electrical room. This worker that's in the forefront working on the equipment, just we're mocking a work task here. They're wearing a vest because their PPE was purchased previous to having the escape strap option. So they're wearing a vest over top that's made of arc-rated fabric, and the escape strap is built into that vest. So if they need to be rescued, the secondary person can do so. Along with the job safety plan would be job briefing requirements. So we've added additions to Annex I. There's actually an example of the pre-job briefing and planning form in the annexes. And then when it gets into the first aid emergency response resuscitation, we've added additional notes to support other CSA standards and tie them together. Trying to move quickly here, sorry, there's a bit of a delay in my function. Maintenance and construction, and the clause for outdoors. So we've just updated some of the terminology here. And we get back into the process for establishing and verifying the electrically safe work condition. There was an important change that was introduced. I mentioned previously how we have a lot of emphasis put on the necessity to achieve an electrically safe work condition, meaning that the equipment has been de-energized and verified as being safe. There in Z462, there's an 8-step procedure that shall be followed. And one of those steps is the verification of absence of voltage. And we've added a requirement within that step that the worker shall test each phase conductor or circuit part at each point of work to verify the absence of voltage. And now I've seen from time to time how some employers believe that you can go upstream of a work location and de-energize upstream and then go back to the work location and proceed with your work. However, that is not correct. You need to ensure that at the point of work, the workers that are performing the work are verifying absence of voltage right then and there. They can't go upstream and do it anymore. This may have been a way to circumvent PPE requirements that you may not have had procured. An example would be if you had a detailed label on that equipment that required you to wear a 75 cal arc flash suit. Well, maybe you thought you can go upstream and de-energize at a point where you didn't require as much arc flash PPE. That wouldn't be the case. You would need to wear adequate PPE. So adequate, meaning that it's rated correctly and that it's suitable for use, that the worker has pre-use inspected the suit, and that it's safe for use. And then this would all be documented in your field level documentation, and that would be done at the point of work. Additional elements of the work permit. So we added content revising that there's, the energized electrical job safety planning form doesn't need to be included in part 2. So there was overlap between some of the pre-job briefing and planning requirements and the energized electrical work permit requirements. So we've cleaned that up in 2024. Testing at the point of each work, or testing at the point of work, that last slide, I'm going to try and go back. That last slide showed an individual using a digital multimeter and having extensions on their leads. There we go. So testing at the point of each work, this is a requirement before you proceed, is to verify absence of voltage using the proper 8-step procedure that's defined in Z462. And now there is an exemption. So for low voltage work where you would need to use a test meter, you can instead install a permanently mounted electrical safety device that can be used external to the equipment, which would be much safer because it reduces the exposure to the individuals that are performing the work task. So this person that's standing in front of the equipment clearly is not wearing the right arc flash PPE because they're not wearing adequate PPE at all. And they wouldn't need to be wearing arc flash PPE if there was no arc flash hazard. Now, if they are using this device that's installed on the outside of the equipment, they can press the button and then they can verify absence of voltage. This is an exemption within the requirements of how to achieve an electrically safe work condition for low voltage. We have a lot of clients that are installing this type of equipment in their facilities in order to reduce the amount of exposure for workers to shock hazards as well as arc flash. I've often said that my son, I have a 12-year-old boy, that he won't be selling arc flash PPE like I have been, simply because eventually employers will get around to installing these permanently mounted electrical safety devices that would then remove the worker from the hazard, which is fantastic. And that's really the whole goal. The intention of the hierarchical approach to mitigating risk is that we don't immediately put workers in PPE. We want to remove the worker from the hazard. We want to eliminate the hazard if we can. And then as part of doing so is de-energizing and verifying that we have a de-energized state. Exemptions to a work permit, we've added exemptions to clarify when a work permit is required and when it's not. The exemptions that we've added relate to normal operation of electrical equipment. That would not require a work permit. Performance tasks that do not involve repairs, modifications, or any alterations of electrical equipment. We have the verification of absence of voltage and installation of grounding. And the last one here has always been, I guess, a stumbling point for most contractors for sure, and probably a lot of industrial and manufacturing employers, is opening up hinge doors, so hinge covers, for the purpose of inspection, provided the restricted boundary is not crossed. So this does then allow, provided that you follow the requirements of the clauses in CSA Z462, for workers to open up a hinge cover for the purpose of inspection, again, provided they're not crossing the restricted approach boundary and not requiring an energized electrical work permit to do so. They still are required to have all their pre-job briefing and planning documented. They still are required to have a shock and an arc flash risk assessment completed, but it's that last step of the energized electrical work permit that would be exempted for these examples. This is the exemptions in the standard is makes up some of the interpretation that's expected of you as the employer when you review the standard and then interpret that as what will be your program, and then how will you train your workers on the application of your program. Training workers on the standard, I don't think gets you very far. It's a good prerequisite, so you can use it to cover off some generalized requirements of the standard in training, but really what matters and what's most effective for workers when you're training on electrical safety is to train on your program and how to apply your program when they're performing their work tasks. And this leads into the documentation. So you can't do all the documentation at a committee level in your office. It needs to be trained. The workers need to be trained on how to complete the risk assessments, so that way they can verify and validate when they're in front of the equipment. An example of why that's important is the condition of maintenance may have changed. You might walk up onto a piece of equipment and something's not right. I mean, you may have water leaking into the e-house. You may have something that there's something is off. Using your look, listen, smell, you might smell burning of insulation. Well, that would immediately cause concern and a red flag that would identify them that the condition of maintenance has changed, and therefore their risk assessment has also changed. So I'm talking about risk assessments and the likelihood of severity. There was changes in having table 2 moved over to Annex F. If you're not familiar with the table 2, I recommend that you do look into table F for 2024. It's a fantastic resource that you could use and interpret as what you then create within your own program documentation. Again, table 2 is the estimate of likelihood of occurrence of an arc flash incident. And this is one of those questions that's commonly coming up in client meetings is, well, when does an arc flash hazard exist? Well, we have this great tool. We introduced it back in 2015, and we've updated along the way for 018, 021, and now we've moved it to Annex F, but it's still there. It's still a great tool for 2024. Here's an example, a really good example, in my opinion, of this is a risk assessment procedure, the risk matrix. So here's a 3x3 example. I don't know what you're using at your company, but this is one example here that we use with our clients. When you take a step back and you look from, say, 20,000 feet above the ground as to the process that must be followed related to arc flash and arc flash risk assessments, I look at it as 4 steps. So first, identify the arc flash hazard. Step 2, assess likelihood of occurrence. That's the table 2, or now the new table in Annex F. Step 3, assess the severity of harm or injury. That relates to the engineering calculations or using the PPE selection tables that we have in Z462. And then step 4 is to apply the hierarchy of control. Arc flash boundary. So we made a change here for hearing protection. It's coming up soon. Updated the term. So of course, we no longer have arc flash PPE category referenced. So we had to make changes to every applicable clause in Z462. And then we have wording changes. This is a lot of editorial changes that come from the global changes. I mentioned earlier that in the tables that are used for PPE selection, there's 2 options in CSA Z462, whereas in NFPA 70E in the US, there's only 1 option. They would have a version of our table 6A. Their version does not have a category 5, and their version, as per their statements, is not based on engineering principles, on the collective experience of their technical committee. On CSA Z462, we did an in-depth review of the table selection method from 2018 and made changes for 2021 to account for new formulas in the IEEE guidelines. So our table 6A is based on engineering principles, and it does have a category 5 requirement. But if you look at 6A compared to table V.1, V.1 being the new table we introduced in 2021, this is where you only need data from the electrical equipment versus needing electrical distribution system parameters on table 6A, which in my assessment, the skill level requirement for workers using the table selection method would need to be advanced based on engineering, electrical engineering principles for table 6A, versus in table V.1, you wouldn't be required to have an advanced level knowledge. You could have a general level knowledge as a qualified electrical worker in order to use the selection method to determine the appropriate protection level of for your arc flash PPE relative to the work task. So incident energy analysis method, we've made changes where we've added some new editorial content. I'm gonna try and skip forward here to keep on track. Table 3, selection of arc-rated clothing and other PPE. So when you're using any method, so in Z462 for 2024, you'll have 2 different paths that you could take. You either have an arc flash study that you've done at your facility, which means you've done your incident energy analysis. And hopefully you have detailed labels that would then provide for you the exposure value that's measured in energy. And from that, you can select your PPE. Now, if you went the other path, which is using a table selection method, you have a few options. You have what will be table V.1 and table V.2, and there's also table V.3. So, but table V.1 is the easier of the others, and there's 2 for AC and 1 for DC. Regardless of which path you take, whether you're using a table method for PPE selection or using the detailed label following an arc flash study, there is a resource that we have provided for you, which is how to select your PPE based on different exposure values. So this was previously table, it's now table 2. It applies to both incident energy analysis and the arc flash PPE selection method. If you have less than 1.2 calories as a requirement, you don't require arc flash PPE. but you need to make sure workers are not wearing prohibited clothing. An example would be that of what is proper to wear would be natural fiber clothing. If your exposure is between 1.2 and 12 calories, you would then select PPE with a minimum ARC rating that is adequate to the exposure, meaning that it is equal to or greater than the exposure. And if you have a scenario where you have an incident energy that's greater than 12 calories, you need to select PPE accordingly. So if your detailed label shows you 55 calories, well, when you're shopping for adequately rated arc flash PPE, you would need to purchase 55 calories worth of protection. Or it could be a 100 calorie arc flash suit that's needed for a 100 calorie label. There is no limit at 40 calories. That's a myth offline about that. The old category selection method was capped at 40 calories. That's one reason why I believe there's this myth embedded in our industry that you can't work above 40 calories. Another reason is this belief that arc blast will kill the worker if they're exposed to anything greater than 40 calories. That's also a myth. I have yet to hear of any workers dying from an arc blast. If you're wearing arc flash PPE, you're gonna survive the incident. If it's adequately rated and it's worn properly and it's suitable for use, meaning it's not covered in some hydrocarbons like oil or grease, you're gonna be okay for the most part. I know we mentioned in the standard that there could be minor injuries, that we can't cover everything with arc flash PPE, but there's certainly no limit at 40 calories. I'm showing an example of a detailed label that shows the incident energy at 56.1 calories. So if I were to have this equipment label example in my work task, well, I would then go to the selection table in Z462, and I would see, well, I just need to make sure I wear PPE that's adequately rated for this hazard. I could go to my closet, I could grab, this would be a 75 cal arc flash suit. This would be, if I wear the full suit, bib overalls, the coat, and the hood, this would be adequately protective, and then I would inspect it to make sure it's suitable for use for the hazard of 56.1 calories. I could also use a higher ARC rating. I could use a 100 calorie suit, or I could even use a 140 calorie suit. We made a change in labeling to ensure that if you are labeling outside, that the equipment label is made of a material that is sufficiently durable for the environment. We don't want labels to be blank when you need to go and look at them and access the information necessary. Other changes here, this has to do with notes that we've added. So there was, in 2021, we added content to both 70E and Z462 that helps provide guidance for when the incident energy exceeds the maximum available protection that's commercially available in the market. So we've added additional clarity to those notes for 2024. And just to help clarify what this is, so the maximum commercially available protection on the market is a 140 calorie arc flash suit. So that's what I'm showing you here on the screen now. That represents the maximum protection that anybody could possibly wear. Now, as long as the incident energy is below that level, that would meet the criteria of the standard. And just as a reminder, 40 cal is not a limit, it's a myth, and safe PPE exists up to 140 calories. There's the arc blast part of that myth. Most of it has to do with the thought that arc blast is relative to the incident energy, but they don't correlate. Incident energy could be really high due to the clearing time of the protective device that's upstream of your work location. But we do know that blast is a factor of containment. So you have the potential for an explosion if you have this rise of pressure inside of a vessel, similar to a bomb. So if you have your cover removed or door opened, that is a way of mitigating arc blast. We also know that any blast is attributed to the short circuit fault current, but the fault current is only one part of the equation for how we calculate incident energy. So therefore, incident energy and blast do not correlate. The actual incident energy has a lot more to do with the clearing time of your protective device upstream. So you could end up with very high blast potential, but low incident energy because of the clearing time. So it's not relative. There's a new requirement here for all workers within the arc flash boundary to wear hearing protection. Previously, it was workers that were performing work needed to wear hearing protection. Now it's when anybody's inside the arc flash boundary. One of my early clients that I was selling arc flash PPE to this goes back 20 years ago, it's a steel mill in Hamilton, Ontario. They had an arc flash boundary that was 100 feet outside their front door. So how they would interpret this new requirement of all workers inside the arc flash boundary needing hearing protection, I'm curious to see how they're going to manage that. But that's the way the new standard will present hearing protection requirements. I'm gonna try and skip ahead here. I'm running out of time. So table 5 standards for personal protective equipment. We've renumbered the tables and we changed the glove protector requirements because we now have the ability for non-leather gloves to be used as protectors. Table 6, all these tables were renumbered. Alerting techniques, this one, I love alerting techniques. And this I mentioned earlier about how do we provide a barrier that is adequately protective for other workers or perhaps other equipment. And as an incident can be an evolving hazard. We know that arc flash is usually an explosion. And if you have fire, fire can start to spread. So this is a way for us to contain or divert an arc flash using a curtain cube. This is also a way that you could use a barrier more in a space that other workers have access to. You know, perhaps it's the public. It's not advancing. Try it again. Sorry, slight technical difficulties. Okay, now we're advancing slides again. Apologies, everybody. I'm trying my best to get the slides to go forward. Okay, so in clause 5, really quick, not many changes here. This relates over to the CSA Z463 standard, which is a standard for electrical maintenance in Canada. There was changes in the annexes. Of course, we brought a lot of tables from the body of the standard into the annexes. Annex H, we did clarify, we missed something in 2021 when we raised the highest category from category 4 to category 5, which has a minimum arc rating requirement of 75 calories. We did not make the update to the Annex H, where in Annex H, there's a 2-level system, and it defines everyday workwear, and it would tell you you should have an arc rating of 8 calories for everyday clothing, and then 1 level higher for when you need an arc flash suit, and it was previously set at 40 calories. We changed that to 75 calories because it allows the category 5 requirements. If you have done an arc flash study or incident energy analysis, and you know you have hazards that are greater than 75 calories, you can make your higher level adequate to the protection necessary. And that may be a 100 calorie suit, it may be a 140 cal suit. And here's just the visual representation for all the everyday clothing on the left, and then on the right was a 75 cal arc flash suit. Annex K, we made some changes. We added shock sequela, which is an important addition to recognize that shock hazards can result, shock injuries, so resulting from a shock incident, they can come back later in life and cause a lot of harm to workers. So that's shock sequela and sequelae. There's a really good resource, which is the ESFI, so the Electrical Safety Foundation Institute, and they publish great documentation on statistics. What I found really good here is good to bring forward and bring your attention to was the 69% number. So 69% of fatalities were non-electrical occupations. So out of all the electrical related fatalities in the workplace, almost 70% of them are non-electrical workers. So please don't spend all your time focusing on just your qualified electrical workers when every worker that's exposed to electrical hazards needs to be accounted for in your training and how you develop your policies and your safety-related work practices. So your preventive and your protective control measures, they need to be applied to both qualified workers and unqualified workers. Additional changes in Annex O, again, this is editorial. Annex V got bulked up because we added more of the selection tables in there. So you have two different methods for AC hazards, and then you have one method for DC hazards. Skipping forward, so Annex W is where we have working with capacitors content we brought forward from 70E. Annex X, this is the bibliography, so we just shifted it around. It used to be Annex W. I'm going to try and skip forward here. We have 10 minutes left, and I want to have some time for questions. So I know one of the questions that I often receive related to a new standard is, what are the next steps? You know, what's required of us as the employer? Every set defines two different types of audits that are required of you. So you have an annual audit requirement, which is the audit the application of your electrical safety program every year. And then you have a 3-year requirement, which is a wholesale audit of your documentation. And that audit, that frequency aligns with the revision cycle to the standard. So if you are implementing a wholesale audit of your program documentation every 3 years, you will capture the new changes and updates made in the current version of CSA Z462. So get ready to do an audit. If you're not doing so already, audits are a requirement of Z462, and they're highly recommended. So audit all of your programs, so your work practices, all of your PPE. If you need assistance, contact your Levitt-Safety representative, and myself, we can go on site. We can inventory all of your arc flash and shock PPE, identify what needs to be retested and recertified, and help put that into a program that can be managed. We're coming up on time. I see Leslie is joining, so I think.
Okay.
Hey, Leslie, there's a delay. I'm just trying to skip forward on the slides.
No problem.
Sorry, I'm still. And still, when you have a new standard published, it's required that you're going to retrain workers. I really encourage you to update your program. Maybe do that in parallel, but at the very least, update your program and then train your workers. Training is most effective when it is your program. So what does your company say about electrical safety? And what are your company's requirements for how to work safely with electrical hazards? That is far more important than somebody standing in front of the group with copy of the CSA standard and just reading clauses. If I stood in front of your workers and I read clauses for 8 hours, I think they fell asleep after the first 5 minutes. So when a new standard publishes, update your program and then train workers on your program again. That's the retraining. Okay, so we're just still working through these slides. Leslie, are there any questions that I could answer while I'm waiting for the slides to advance?
Absolutely. So first question is, you mentioned that the CSA standard isn't written into any provincial or federally regulation currently. Is this also the same for NFPA standard as well?
There is one legal requirement in the US for 70E, so not in Canada, but in the US, and it's the Department of Defense contractors. So the DoD contractors are the only group that are required by law to follow NFPA 70E. Otherwise, it is voluntary, similar to CSA Z462. Now, I say that with this asterisk that it's voluntary because you still need to follow something. You can't follow nothing. And I don't know what else you're going to follow. If you're in Canada, Z462 is a national standard. You have to be living under a rock for the last 15 years in this industry to not have heard of it. And the same goes for 70E. 70E has far more history and prevalence in the world, not just in the US, but in the world. So you need to follow a standard, and you could pick or choose. I mean, if you want to follow 70E, and you're located in Canada, you're going to be missing on some of the requirements. We do have differences between the two standards.
Okay, great. I had a question on the ARC blankets. Do they have voltage ratings or limitations?
They're not meant for shock protection, so they wouldn't have a voltage rating. They
Okay.
are rated based on amperage. So they're rated based on 15 kA, 25 kA, or 40 kA systems. Typically, they're a blanket that will be a 4-foot by 5-foot blanket, or so there's a 5-foot by 8-foot blanket. Those are the common sizes. The blankets would have a rating on the label. So this blanket, this is a little sample, but this blanket is a 25. Oops, there it is. So this is a 25 kA blanket, and then it gives you a BTP rating. So that's actually similar to a break open threshold rating, or what the maximum would be for its exposure.
Okay.
For my camera to refocus on me.
Okay. And we also had a question, if you de-energize the panel or equipment to negate the need for arc flash PPE, wouldn't it still make sense to wear it or verify absence of voltage?
I need to, if you can reread that question.
For sure. If you de-energize the panel or equipment to negate the need for arc flash PPE, wouldn't it still make sense to wear it to verify absence of voltage?
So the process of de-energizing, if there is a threshold that's been passed for when an arc flash hazard exists, you would then still need to wear arc flash PPE to verify absence of voltage. So first you have to ask yourself in the risk assessment, does an arc flash hazard exist? Is it possible? I mean, if you're talking about a receptacle on the wall in your house, there's no arc flash hazard. But if you're talking about a voltage level that can sustain an arc across a gap, which then can transform into an arc flash, well, then if you're de-energizing that and you're verifying absence of voltage where you have the potential, when you're using a test instrument, you're touching phase to phase and phase to ground, you need to wear adequate protection. So the process of de-energizing usually requires that arc flash PPE is worn. Once you have achieved this electrically safe work condition, you verify it as part of that process, you verify the absence of voltage, then you no longer require arc flash PPE, unless there's some other hazard that you are also trying to protect yourself from.
Okay, great. Had a question on the hearing. Does the standard cover the types of hearing protection that should be worn, i.e. earplugs versus earmuffs?
It just says hearing protection. No, with earmuffs, I often believe earmuffs are required as dual hearing protection, just simply based on the exposure level. But please don't shoot the messenger. I don't think it's being used properly in terms of selecting your hearing protection and what would be adequate for its attenuation level. I know the testing that's been done or performed in the industry. I've seen tests where we've actually taken earplugs and tied them on a string and exposed it to an arc flash, and all the earplugs light up. They're not FR. The best ones are actually the most inexpensive, where you can use little, like the shape like a barrel, and you roll them down and insert them in your ear. I think we can all rest assured that if you're wearing adequate PPE, your earplug should never be exposed to an arc flash. And if you want to wear earmuffs, because you do want to have the ease of an earmuff versus an insert, you just need to have, you have to have a hood, some way to protect that earmuff.
Very good. And we have time for one last question.
Just one more thing, sorry. What I meant by if you're wearing your PPE correctly is that you either have a balaclava or you have a hood. You should never have your ears exposed to an arc flash where the earplug could be ignited.
Good to know. So our one last question is, is there a hard and fast rule when we need to wear arc flash protection when going inside an electrical panel?
Your risk assessment. There's no hard and fast rule. There's nothing that is hard and fast about safety. Safety is complicated. Safety requires education, requires knowledge, requires dedication, and a lot of effort in order to implement and maintain. So you need to step back and do a risk assessment. First, look at your shock hazard. Does it exist? Can I be exposed to some energized conductor or circuit part? Yes or no? And then how do I mitigate that risk? I have to apply the hierarchy of controls. And then after shock, you got to look at your arc flash. So does an arc flash hazard exist? Yes or no? And then how do I mitigate that? What is the severity? What is the likelihood that I'm going to make contact or that an arc flash can initiate?
Very good.
Thank you so much, Jim, and thank you everyone for attending today's webinar on Arc Flash PPE and the changes to CSA Z462 to Workplace Electrical Safety Standard. If you have any other questions, please contact one of our Levitt-Safety representatives and they will gladly assist you. Once you leave today's webinar, you will receive a survey on the presentation, and we would appreciate it if you would complete that and provide your feedback. You will also receive a follow-up email with a link to view a recording of today's webinar. Have a wonderful afternoon, stay safe, and make sure to subscribe to our YouTube channel and follow us on LinkedIn, Facebook, Instagram, and the X for the latest safety content and expertise across Canada. Have a great rest of your day, everyone.
Thank you.